Hello everyone. Can you see my screen and hear me?
Yep, audio and screen's good. Thanks.
Okay. Hi. I'm the PI for the project SafeSci-TEE. This project is trying to develop a comprehensive solution to provide a secure environment for the scientific workflows in a shared HPC clusters. Why it matters? Because the HPC clusters usually is shared across different users, across different tenants. There, they often run the scientific workflows. The scientific workflows, they often need to share the data and the computations with the collaborators from different institutions. Even in the traditional supercomputings, the co-tenants or the users could be adversaries posing the risk to the data. Um, the motivation stems from the sensitivity of data and modules involved in the scientific workflows because these workflows often operate on the confidential or critical data, um, such as the patient genomes. Um, yeah, right now the confidential computing, this concept is pretty popular in industry. They typically leverage the hardware TEEs from the major CPU vendors, like the Intel has their TDX, AMD has SEV, the ARM has Trusted Zone to protect the computations on the potential untrusted hosts. But however, simply deploying the TEEs is not sufficient. We need the additional mechanisms for attestation and verification are essential to ensure the workflows can be safely run, not only within the node, but also end to end. Especially within that multi-tenant environment. This project, how to from the software point of view, can have the TEE better support and provide a secure environment. It definitely has several of the challenges. We For this project, we cover with three thrusts. The first thrust is within the same node. Within the same node, typically the solutions primarily focus on the initial attestation, leaving the runtime behavior or workflow components vulnerable to be hacked. So in the first thrust, we try to provide achieve a continual runtime integrity assurance in a scalable, efficient, and non-intrusive manner, while accommodating the unique characteristics of the scientific workflows. This is the first challenge what we are facing. So for solving that challenge, we will develop the novel techniques for contiguous runtime attestation of the scientific workflow components. Executing within the TEs, we will extend the measurement capabilities of TEs to capture the comprehensive runtime, not just the start time, but the runtime, the state information, and design the secure attestation protocols to enable the verification of workflow during the lifetime of the workflow. The second challenge, because one node you have the limited capacity for the scientific workflows, it usually is large, will involve different nodes collaborate together to finish the work. So the second challenge we are looking at if application involve the workflows spans across the different nodes, how can we ensure the end-to-end integrity for this distributed scientific workflows? This is complex, not that easy to solve, because establishing the comprehensive framework for the end-to-end integration verification, where the trustworthiness of each flow step can be tested and verified in relation to the overall context that requires novel approaches to the distributed and aggregate trust evidence. To solve that challenge, we will establish a framework for the end-to-end integration verification in the distributed scientific workflows. We will create the mechanisms to propagate the trust across the workflow stages, develop protocols for efficient and scalable attestation of distributed components, and explore the techniques for maintaining the confidentiality of sensitive data in the collaborative settings. The last challenge we are trying to solve is because the HPC clusters they have different TE environments. We have talked about different vendors. They may provide different their API, their libraries is different. How can we in that heterogeneous environment provide a hardware agnostic TE integration and then secure the workflow scheduling? Integrating the TE-based security mechanisms into these diverse HPC environments. This is another challenge we are facing. So to solve that challenge, we will design the hardware agnostic TE solutions and secure the workflow scheduling algorithms. We will develop some abstractions and the runtime systems to enable the seamless integration of TEs across heterogeneous the TEE environments, which can balance the security, the performance, and the resource utilization in this shared HPC environment. It's obvious that it will have some risks for the solutions. For example, I can list one risk with this contiguous attestation. How can we manage the overhead? With the confidential computing, to be safe, it will involve different message copies. How can we leverage the hardware accelerations by designing some optimized protocols and with some kernel environment, less kernel environment to optimize, mitigate this kind of overhead. So without this, the scientific collaborations will limited by some security concerns. When the users use that, they always have the concerns whether their data will be leaked, will be hacked, whether their results can be stolen, something. They will have this different kind of the concerns with our solutions. We can have the institutions can collaborate in a more confident way and can have their data be verified. The scientific results can be verifiable and producible, provide a safe HPC sharing environment. We will have the system gets developed and open source by following the Apache 2.0. With our development of for the tests at UConn, we have the HPC clusters. We also have the collaborators like the National Lab from Berkeley. We will also work with them to verify the solution, deploy to try it indeed bring the values, and we will also publish at the top tier system or security conferences. This is a 3-year project, begin from the September this year. It's led by the University of Connecticut. So we also have some collaborators from NVIDIA, from the national labs. That's all.
Great.
Thank you.
Thanks so much. This is good. So I think these three all kind of continue a similar sort of trend about a lot of great stuff. Really important to have that open source software to make the results public. Less less directly data intensive, but still I think some good opportunities for inclusion with NDP and OSDF and benchmarking will be important for all these. So cool.